Hey, sixth grade, welcome to our skills practice lesson for today. Today, we're going to continue what we've been working on all week, which is order of operations. We're really going to be focusing today on the structure of how we solve expressions, as well as maybe getting a more understanding of like how we use order of operations and why we use them the way we use them to solve expressions and, in other words, evaluate them. So hopefully today is another chance for you to practice this skill because it is extremely important. And then we're going to get an opportunity to actually go ahead and show whether we understood how it works now, and if this reteach actually helped out, if at all. So the whole goal here is for you to try your best, see if you can do the work, and then we'll see what happens after this. Hopefully today is a lot more helpful in helping you understand how we actually go about solving expressions. All right, so let's look at our objective from lesson 3. Remember that our objective, oh my goodness, I cannot speak this morning. Our objective has not changed. We have been working with the same lessons, so our objective is very similar. We're still evaluating numerical expressions involving whole number exponents and grouping symbols following the order of operations. So we're going to really be focusing on using the order of operations. So one thing I do know is that you may look at an expression like this and be like, whoa, this is a lot. I have no idea where to start. I don't know what to do here. There's a lot of things going on. And I get it. It is complicated. The beginning of our foundation of algebraic expressions does start in sixth grade, so I can see where this can be extremely confusing. Now, I don't blame you for looking at this being like, I don't know where to start. I don't know what to do here, Mr. Sarah. But the hope is at the end of this lesson, you'll get a better idea of what an expression is and its structure, as well as how to go ahead and solve it. Now, we're going to go ahead and look into like what really makes up an expression. And I'm not talking about coefficients or constants like we did before, more so like what is the math that makes up expressions. So realistically, one thing we do know is expressions are a series of operations of addition, subtraction, multiplication, or division between two numbers. When we're solving expressions, we're looking for what operation we can do with two numbers. And we're only really working with two numbers. So like we're looking to see, can we multiply 2 into 4? Are we going to add 2 and 4? Are we going to divide or subtract 4 minus 2? Are we going to do 4 divided by 2? I'm always looking to see what math I can do with the two numbers that I'm looking for. That's where our understanding of Gandalf really comes in. As Gandalf is really used for us to figure out what math am I doing with what two numbers. So when I'm actually going to solve an expression and I'm taking it step by step, I'm only solving parts of my expression that involve something to do mathematically, adding, subtracting, multiplying, or dividing with two specific numbers. Everything else that leads up to that is just trying to figure out what those two numbers are. So for us right now is just the understanding that when we're solving expressions, we're really just looking for some math to do with two numbers, and we do that consistently. It'll get us to the point where we actually solve the entire expression. The only exception to this rule is exponents. And the reason why exponents are exceptions is because they don't normally involve two numbers. They still involve multiplication because we know it's repeated multiplication. But as we can see here, that exponents actually can be more than two numbers. So when you see an exponent, remember our base tells us the number that repeats, and our exponent, the number on top, tells us how many times it repeats. So when I look at this exponent, I see that it's 3 to the 4th power. That means I should multiply 3 4 times. So as I look at here, here's 1, 2, 3, 4. I'm multiplying this 3 4 times itself, and that's how I get my value. So if I do the math, 9, 3 times 3 is 9. 9 times 3 is 27. 27 times 3, it is 81. That's the answer. So the only part of our expression that doesn't follow the rule of an operation with two numbers is exponents, because it will normally involve more than one number, and it's going to be the same number as your base. But it's important to note that that's why this in our order of operation is on its own, because it doesn't follow the same rules as it does with operations, with multiplication, division, addition, subtraction, which we'll see later on. Now, the last thing I do want to go over is there is groupings and expressions, and this is why when we think about order of operations, groupings is first. But when we do an expression and solve it with that doesn't have any groupings, doesn't have any parentheses or brackets or braces, we use our normal understanding of math, right? We're always going to multiply or divide first before we add and subtract. So knowing that, I'm going to go ahead and solve this. So I know I want to multiply first. So here's my multiplication problem, 5 times 6. I want to do that first. Remember, look, once again, solving an expression is a series of doing math with two numbers. What am I doing here? Well, I'm multiplying 5 times 6 first. The operation is the multiplication. What two numbers am I working with? The 5 and the 6. So I will go ahead and get that answer. 5 times 6 is 30. I want to rewrite my expression. And now all left is addition subtraction, which is always going to be last. And I work it from left to right, which means I'm going to work with this part first. It's the furthest to the left. 20 plus 30 is 32. I'm replacing what I circled with the answer, rewrite everything else, and then my answer is 30. Now, the reason why I went through this process for you to understand what groupings really do. When we see a grouping in our expression, as you do here, you definitely see a grouping here. Anytime you see a grouping, what I want you to think of is this, that it says do me first. Whenever you see parentheses, what it's telling you mathematically, it says you need to do this first. What's inside the expression can still be a series of operations. It could still be you trying to figure out what math you're doing with what two numbers, but you're going to do that first before you do anything else. This is the same exact expression as the one before. The only difference is that I have grouped this first part of my expression. And if we look back at the one previous to this, the first thing I did with the previous expression is I multiplied 5 times 6. But because of the parentheses, it's telling me I need to do this first. And because of that, instead of multiplying 5 times 6 first, I'm going to go ahead and add this 2 plus 5. I'm going to do everything that's inside my grouping first before I get to the rest of this expression. One thing I do want to make note of is like in your groupings, you could also have additional groupings. So we still got to go back and follow our order operations, which you will see later. But we want to just get the understanding that a grouping here says you need to do this first before you do anything else. That's why we use groupings in math. So I need to go ahead and do this 2 plus 5 first, which gives me 10. Rewrite everything again. Once again, multiplication comes first before subtraction. So I'm going to go ahead and do multiplication first. 10 times 6 is 60. 60 minus 2. Well, that's the last thing I need to do. So I'm going to circle that is 58. Notice a difference in our answers just because a part of our expression was grouped. Here it's 58. We look at the one previous to this. The answer was 30. So a grouping does make a huge difference. And once again, when you see a grouping, when you see a parentheses, when you see a bracket, when you see a braces, it means do this first. This is why in our order of operations, our groupings are the first thing to do. I want to do what's inside that grouping first before I do anything else. And as we talked about exponents, there's a reason why they come next because they don't follow the normal rule of an operation between two numbers. So I always want to make sure I get rid of those exponents first, and then the last two are just our regular math that we are so used to doing, adding two numbers, multiplying two numbers, dividing two numbers, subtracting two numbers. This is why they come last. We always want to do multiplication and division first before we do addition and subtraction. But you have done your expression right if the last thing you're always left with is addition and subtraction. That means you have gone through your steps properly. Now I'm going to review essentially what we're going to be doing and how we want to use this understanding to solve expressions, right? We want to figure out what two numbers I'm working with and what math am I doing with them using my order of operations. Let's get into that. But before we do that, let's look at the steps we're going to be taking. So here are the steps that we're going to be taking to solve an expression. Don't worry about memorizing this. You're going to see me put this into practice here in about 2 seconds. So I'm going to underline the part of the expression you're working on using GAMDOS. I'm going to use GAMDOS first to figure out what part of the expression should I be looking at. After you do that, I want to use GAMDOS again. I want to use my order operations to determine and circle what operation I should be doing. What math should I be doing? Once I figured out those two numbers and the math I'm doing that I'm working with, or the exponent that I'm working with, then I want to go ahead and solve it, rewrite the expression, and I want to replace what I circled with the answer. And the last thing I'm going to do is repeat the steps 1 to 3 until I have simplified or I have evaluated my expression all the way to one value or to one answer. So let's look at what this actually will look like in your work today. So here's a perfect example of what it'll look like. I will give you this V. You know that you've done it correctly when you see this V in your work. That means that you're going from this really long expression all the way down to one single answer. So let's practice how this works. The first thing I want to do is use my order of operations. And I'm actually going to physically show you how I'm going to use my order of operations on the side to determine what I should be working with first. So I'm going to ask myself, do I see any groupings? Well, yes, I do. I see one huge grouping here. Now, I want to do everything that's inside the parentheses. So I want to do everything that's inside here first, but I want to go back and check to make sure that I'm doing it in the right order, because when it comes to math, order does matter. So I want to go back into my order of operations and determine what two numbers am I going to work with and what math am I going to do. As I look inside this parentheses, do I see any groupings? No, I do not. Do I see any exponents? No, I do not. Do I see any multiplication or division? Yes, I do, and that's what I want to circle. So here's my division problem. I want to circle that first. That's the first thing I'm doing. 10 divided by 2. Well, I know that answer is 5. I'm going to go ahead and replace this entire expression and rewrite it, and I'm going to change this 10 divided by 2 with the 5. So my 2 stays the same. I haven't changed it. I'm multiplying 2. The parentheses still stays here. Well, what am I multiplying 2 times? Well, parentheses, I'm replacing this with the 5, so it stays as a 5. I haven't used this plus sign because it's not circled. Plus 6, keep my parentheses, minus 7. I want to go back using my order of operations to determine what I need to do next. Now, as I look at this, do I see any groupings? I still see groupings in this expression. Here's still a parentheses here that I rewrote. So I want to go ahead and underline that. Now, in this parentheses, do I have any groupings? No. Do I have any exponents? No. Do I have any multiplication division? I do not. Do I have any addition subtraction? Yes, I do. I'm going to go ahead and just circle that because that's the math I'm doing. 5 plus 6 is 11, and I want to rewrite everything else. My 2 is still the same. I'm still multiplying 2, but now instead of the parentheses and the 5 plus 6, I'm just going to write 11. 2 times 11 minus 7. Now I have a new expression, and I want to go ahead and go through my process again and use my order of operations to determine what I should do first. In this expression, do I see any groupings? I do not see any groupings. Do I see any exponents? I do not. Do I see any multiplication or division? I do. I see multiplication. Here it is. I'm multiplying the 2 and the 11. That's the only two numbers I'm working with. So I'm going to go ahead and circle that. 2 times 11, what is that? Well, that's 22. So I'm going to go ahead and replace that thing I circled with 22. Bring down everything else I have not circled. So I did not circle the minus sign, and I did not circle the 7. So now all that's left is 22 minus 7. And just so that you can see the process that I do again, I'm going to go ahead and ask myself, because it's a new expression, if I have any of these order of operations in my expression. Do I see any groupings? I do not. Exponents? I do not. Multiplication, division? Nope. Addition, subtraction? Yes, I see a subtraction sign. That's what I'm going to do. 22 minus 7, that's going to be 15. One thing I want you to keep in mind is look at the series of operations that I did to get to my answer. In the first part, all I did was 10 divided by 2. In the second part, all I did was 5 plus 6, and then rewrite it. In the third part, all I did was 2 times 11. In the fourth part, all I did was 22 minus 7, and I did it until I got to the 15. So I'm looking for what two numbers I'm working with and what math I should do using my order operations. In general, we're always going to get down to multiplication, division, addition, subtraction. Grouping just says do that first, and exponents, you will see in a second how those come into play. Let's do another example. So this is exactly how your work's going to look. I've given you the boxes. Your job is to fill them in until you get down to the last value. So once again, I'm going to go ahead and take my time. And this expression is extremely similar to the one we did prior. The only difference is that 2 has a exponent in it. So let's go back and look at the previous expression. Same expression, this one without the exponent. This one does have the exponent. So you're going to see how exponents come into play when we do our work. Now, once again, I want to go ahead and use my order of operations listed to determine what part I should be looking at first. Do I see any groupings? Yes. So I want to make sure I'm looking at what's in the parentheses first, then go back into my order of operations and determine what math I should do with what two numbers. Well, let's look at this. Do I see any groupings in this grouping? I don't. Do I see any exponents in this grouping? I do not see any exponents. Do I see any multiplication or division? Yes, I do. I see division. I'm going to circle that. That's what I'm doing. I know that 10 divided by 2 is 5. So I'm going to replace this with 5. So I'm going to keep my 2 squared. That hasn't changed. I haven't circled my multiplication, so I'm going to stay the same. I did change this. It's 10 divided by 2 is 5. So I'm going to replace that with 5. I want to keep my parentheses. I haven't got rid of it. I'm going to add 6. Keep my parentheses. Minus 7. Go back to my order operations. I'm going to use a different color so that you can see it. Now, as I look at this again, do I see any groupings in this expressions? Yes, I do. I still see the parentheses here, so I want to underline that. That's what I'm working with. In this grouping, do I see another grouping? I do not see another grouping. Do I see an exponent? I do not see an exponent. Do I see multiplication division? No. Do I see addition or subtraction? Yes, I do. I see an addition problem. I'm going to do that first because the parenthesis says do that first before anything else. 5 plus 6 is 11. So I want to go ahead and replace this, what I circled, with 11. So I still have 2 squared because I haven't gotten rid of that yet, times 11. I don't need to include the parentheses because once it's down to one number, you can get rid of the parentheses, minus 7. Okay, so there is my new expression. I'm going to go back and do the same thing I just did. Make sure I pick the right color. I'm make sure we can see it. So I'm going to ask myself again, and notice how I am checking on my order of operations to make sure that I have determined that there's not there or it is there. Do I see any groupings in this expression here? No, I do not. Do I see any exponents? Yes, I do. I want to do work with this first. I know that I need to evaluate this exponent before I do anything else. So I'm going to circle that. That's the math I'm doing. Remember, an exponent is repeated multiplication. It is the base, which repeats, and the exponent tells you how many times you need to multiply that number. I need to multiply 2 times. So it's going to be 2 times 2. That is 4. So replace this with 4. So I have 4. It should be one more here. So let me actually rewrite this the way it's supposed to. It's supposed to be one more square here. So it should be 4 because I got rid of that 2 to the second power, but I did not get rid of the multiplication sign. I did not get rid of the 11, and then I get a subtraction sign or the 7. So now I have 4 times 11 minus 7. Now, as you get really good at this, you'll be able to notice like what you should do first just by looking at the expression. But I still want you to go back and do your checks. Do I have any groupings? No. Exponents? No. Multiplication division? Yes. I need to do this first. Multiply first. 4 times 11 is 44. Keep the minus sign. Keep the 7 sign. Once I have a new expression, go back and check again to make sure that I have nothing else that I need to do first before I do this last thing. Do I have any groupings? No. Any exponents in this expression? No. Any multiplication or division? Nope. Any addition, subtraction? Yes, I see subtraction symbol. That's what I want to do. This is the last thing I want to do. 44 minus 7, and my answer should be 37. What I'm really looking for in your work is this. Are you correctly circling the math or the two numbers and operations that you should be doing? For example, you should, when I look at your work, I should see that you underline the parentheses because that's what the part of the expression you're working on. And then I want you to circle the division symbol because that's what you should do first because division comes before I do addition. So 10 divided by 2. Notice how I replaced that number in my square, rewrote everything else. I didn't circle to the second power, rewrote it. Didn't circle the multiplication sign, rewrote it. I didn't get rid of my parentheses yet, so I rewrote those. Didn't get rid of the plus sign, rewrote it. Didn't get rid of the 6, rewrote it. Didn't get rid of the subtraction sign, rewrote it. 7, rewrote it. Then I went through my order operations. What do I do next? Well, I still have a grouping here that I need to get rid of. Underline it. Do I have anything else in here that I need to do? Well, let me check. There's no grouping in here. There's no exponent in here. There's no multiplication division, but there is addition subtraction. I circled that. So we notice the series of operations that I'm doing to get to here. 10 divided by 2 first, then 5 plus 6, then 2 to the second power, then 4 times 11, then 44 minus 7, then I got my answer. It's just a step of doing operations till I get to my final answer. All right. Which real quick, I just want to go through what it looks like to do this with expression that has grouping within a grouping. So once again, I'm gonna go through my checks. Do I have any grouping symbols here? Well, yes, I do. I have a grouping symbol. You can see here there's a bracket. I was going to circle the biggest grouping symbol I have. So notice it stretches the entire, almost the entirety of our expression. And I want to go back and check. Do I have another grouping in here? Well, yes, I do. I have this grouping in here, and I want to do that first. This is going to be first inside this grouping that I need to do. So I go back and look again. Do I have, let me change the color real quick. Do I have another grouping in this grouping? I do not. There's no other grouping in there. Is there an exponent? There is not. Is there multiplication or division in here? There is not. Addition and subtraction? Yes, there's both. And we know that when we have addition and subtraction, we do them at the same time from left to right. So I'm going to do the 3 minus 2 first before anything else. And I'm just going to worry about this operation, not anything else. 3 minus 2 is 1. I want to rewrite everything else. This plus 4 still stays. I still keep my brackets and my parentheses because they're not gone yet. The minus sign stays. Sorry, minus sign here. 6 stays. The multiplication symbol stays. The 4 stays. The bracket still stays. The plus sign and the 5 still stays. Note how I replaced everything. The only thing I changed was this 3 minus 2 to get 1. And let me go through my steps again. In this, do I see any groupings? I still see a grouping. It's still this giant grouping. Go back. Do I still see another grouping in this grouping? Yes, I do. I still see this parentheses right here. And I want to solve what's inside. So I want to go ahead and do the 1 plus 4, which I already know is 5. And once again, once I only have one value, I can get rid of the parentheses or the grouping symbol around it. But the thing that still stays is the bracket. So I have 5 minus 6 times 4 with the bracket plus 5. Same process. Do I have any grouping symbols? Yes, I still do. I still have this giant bracket here. In this bracket, do I have any more grouping symbols? No, I do not. Do I have any exponents? No. Do I have any multiplication division? Yes, I do. I have multiplication. 4 times 6. I want to do 4 times 6 first. That equals 24. So now I have 24. Oh, there it is, 24. Minus 5. The bracket still changes because it's still something I need to do in there. Plus 5. Within my same process, do I have any grouping symbols? Well, yeah, I still have a grouping symbol. I still need to get rid of this bracket. So yes, I still have a grouping symbol I want to work with here. Do what's inside. So I need to do 24 minus 5. That's all that's left. That's 19. Because it's just one answer, I can get rid of my brackets. I don't need to keep it. Plus 5. Go through my same process again. I have a new expression. Do I have any grouping symbols? I do not. Do I have any exponents? I do not. Do I have any multiplication division? I do not. Do I have an addition subtraction? I do. I have an addition problem. 5 plus 19, which is 24. Notice how a lot of this is just looking to see if you have any grouping symbols. Because once you figure out the groupings and you're going to do that first, then you can go ahead and do the rest of your math, right? And you're asking yourself, is there a grouping in the grouping? Well, I know I have this giant grouping, but I want to do what's in the grouping in that grouping first because it's literally what I need to do first. And then you're going to do your math. Either it's going to be exponents, multiplication, division, or addition, subtraction. So the grouping is extremely important, and it just tells you to do that first. And once again, it's a series of just operations with two numbers. 3 minus 2 first, then 1 plus 4, then 4 times 2. sorry, 4 times 6, then 24 minus 5, then 5 plus 19, all the way to get to my answer. So you're looking for what two numbers am I working with and what operation am I doing with. Once again, the only exception to that is the exponent. And when you see an exponent, it just means repeated multiplication. So hopefully this helps. This is what I want to see in your work today. I want to see the underlining. I want to see the circling so that I can determine. You will have these boxes as well for you to do your work. So I want to see that you correctly evaluate the expression all the way down until you got your answer. So I want to be seeing that you went ahead and got to this final part. Just to show you what your work will look like today, it looks like this. And once again, you will have the boxes for you to do the work. And the expectation here is you're underlining the part expression you're working with, you circle the operation you're doing, and you're going to rewrite the expression. So I want to be seeing that work here as you are doing it. Best of luck, Kipsters, and I will see you on Monday. Have a great rest of your day, and hopefully you get this done for some extra credit on Unit 3, Lesson 3. See ya.